Hello and welcome back to the CCENT journey with me, Ryan. And in this section we're going to continue with part 2 of Telnet, SSH and banners. In the previous video we focused primarily on Telnet. We looked at some of the key components of Telnet and what we need to know about it for the CCENT certification. And then we actually dived into packet tracer and configured Telnet. And then at the end of the video we done a packet capture and looked at why Telnet is insecure and seen that plain text between two devices. In this video we're going to pick up what we learned from Telnet and move it to SSH, so I will not be going over some of the stuff we talked about in Telnet, but we will actually be configuring SSH inside packet tracer, and then we'll be finishing up the video with banners. For those who don't know, you can contact me here on YouTube, on LinkedIn or Twitter. So what do we need to know about SSH versus Telnet? So just like Telnet, it uses TCP, but in this case it uses port 22. And the most important thing between SSH and Telnet is that SSH is actually secure, and it's secure because it uses encryption. Now we saw in the previous video, I set up a Telnet from a client to a router, and then we used packet capture, and we could see everything that I was typing in the terminal, it was appearing in the capture. Well, with this SSH, we do the same thing in this video, but we'll actually see that that traffic is encrypted. And if I try to look at the TCP stream within Wireshark, we can't quite make out what it's doing there because of that encryption. So just like in the previous video, SSH is the recommended protocol to use, and we try not to use Telnet in our environments anymore. Now it's a few commands to remember, just like the previous video. Now one key part is, if you haven't seen the previous video, then you need to go back and watch it. The previous video has a ton of commands that we're not going to talk about in this video, primarily around kind of like the VTY bit of it. We don't talk about what is VTY, we don't talk about the password and username too much. So if you want to understand that, and you want to understand about the transport input command, you need to go back and watch the previous video. Unfortunately, I don't have enough time in these videos to keep going over every single bit of information. That's why we've got to watch them in order. So go back and watch that. The transport input command, now it's something we did talk about in the previous video. We said that you have kind of primarily three options at the CCENT level. You have the default option, which is OR. And then you can actually specify whether you want Telnet or SSH to be listening on these particular VTY lines. Now, normally you can just put in SSH, but because this lab environment that I have set up, we're actually going to use OR, because despite the fact that it's only two routers connected back to back, I am actually up here using Telnet into one of the routers, and you'll see that when we get into the lab. So make sure you watch the previous video. Now, along with everything we discussed in the previous video, we need to know what additional commands are needed for SSH. Now we know that you have to change the transport input, and we even discussed that in the last video, but in this video we're going to focus on understanding the difference in the SSH commands. So it's really important that we set a domain name. So in this example I set test.com, but normally this would be your domain name for your company. And it needs a domain name because it uses that domain name to actually generate what we call our keys. So we generate some RSA keys, and those keys allows the secure transfer between the client and server for SSH. And then a optional, and sometimes, very sometimes, a default command on the newer platforms is the use of IP SSH version 2. But what you'll see is version 2 actually requires a higher bit key. And what I mean by that is when you generate your keys, you can generate sort of how secure you want those keys, or how large you want those keys. So by default, I think it's 512 bit, but you have to have it, I think it's, I don't know, 768 or something higher for SSH v2. So if you have a particular security policy in your company that requires you to have SSH version 2, then you have to generate larger bit keys, which in this day and age doesn't have too much effect on the hardware, but ultimately it does mean that the CPU to generate those keys is obviously going to have a high load to do. So what we're going to do now is jump into a lab environment, 2 routers connected back to back, and then we're going to set up SSH. One thing you'll notice is I'm not using packet tracer in this video. The reason for that is because I tried using it in packet tracer and I was getting all sorts of odd results, and it wasn't working as the Cisco docs implied it would. So I've actually span up 2 actual Ciscos, and we're doing it in 2 actual real Ciscos rather than packet tracer. So let's get started. Okay, so here we are inside a lab. We have 2 routers connected back to back. If we do show IP interface brief, we can see that we have the gig 1.10 interface is what we're concerned about here. And you can see that we have 10.0.0.1 and 10.0.0.2. Now as for the gig 1 interface, just ignore that. That's for remote management to allow me to get into these boxes. Now we're more concerned about router 1 in this instance, because router 1 is going to be where we're going to SSH into from router 2. And let's have a look at router 1's configuration currently. So first of all, we got an enabled secret setup that will allow us to get from user exec to privilege exec. We have the interface set up that allows us to connect from router 2 to router 1. And then we have the VTY configuration already in place. And the reason it's in place is because currently I am telnetted into router 1 and 2. So we can see that the VTY 0 to 4, we can see that the privilege level is set to 15 as a password of A, and login is turned on. So what we're going to do is configure SSH. Now the first thing we need to do is actually try to SSH now and see what actually happens. So we type in SSH on router 2 and question mark it. We get a bunch of options, and one of the options is to obviously just pop the IP address in. But what we are going to do is actually use this, the -L command, to specify a username. Now of course we both know, because we looked at router 1's configuration, that Ryan is not configured. But if we SSH onto it, and actually popping the IP address might help. If we SSH to 10.0.0.1 with Ryan, it actually completely aborts the attempt to try and connect to it. So what if we were to create a local user called Ryan, and then once we create that local user, remember from the previous video, we had to go into the VTY configuration and tell it to use the local username and passwords. So config T, line VTY, login local. We're going to create a username. Username is going to be called Ryan. We're going to give him the privilege level of 15 and the password of A. So the privilege level of 15 means that when someone called Ryan connects to a VTY line that's now set up for login local, I would go straight to the privilege exec mode or enable. So now let's give it a try. And same issue, still getting the problem of the error status. So still no luck there. Okay, well, what if the VTY line is not set up to listen for SSH? So we'll go under the VTY, transport input. Let's set it to OR. Now I could set it to just SSH, but if I do that, I'm going to lose connectivity because again, I'm using this VTY line currently. So let's set it to OR. And again, still not getting anything there. Now to confirm I'm actually using it, if you type who, you can see that I'm on the 192.168.0.101, and that's how I'm telnetted into this box. So we're still getting no luck with the actual configuration, despite the fact that I've typed in SSH, we've got the username, and we've created that username locally, and we have the VTY line set up to listen to SSH, but unfortunately I'm still getting this error status. So why do we think we're getting this error status? Well, it could be for many reasons, but what's going to be more important is actually have we set up SSH? And one part of that from the previous PowerPoint, the key part was we have to set those crypto keys. So let's go to global config and set up the crypto key. And the way we do that is we type in crypto key. It's going to ask us, what do you want to do? Well, I want to generate some new keys, please. We want them to be the RSA keys, and we're going to hit enter. Straight away, we get a message. Please define a domain name first. So we know again from the PowerPoint presentation, one of the requirements is to have a domain name set. If we don't have a domain name set, we can't generate these keys that allows us to encrypt the traffic when we SSH from a client to a server. So in this case, let's go ahead and generate those keys by first of all creating that domain name. So IP domain dash name. So obviously here you'd put in your company's domain name, but let's just give it test.com. Press up and let's try to generate the keys now. It now says you already have RSA keys defined for r1.test.com. Do you really want to replace them? Now the reason it's come up with this is because I actually done some keys generating using test.com previously prior to the video to make sure that I was able to do it in this box. But let's go ahead and replace them. And what you would actually see is instead of this question, because the keys already exist, you would get asked, just like we are now, how large of a key do you want to produce? So the default is a 512-bit key. Obviously we can increase that up to 4096, but the larger the key bit, the more CPU power the box takes. In this instance, I'm just going to leave it with the default, and it generates those keys. Now if we were to have a requirement in our company to use SSH version 2, and we had to move to version 2, notice that you have to have a minimum of 768 bits for V2. And because we've got 512, that's not going to be acceptable. So what if now we have our keys generated, we have our domain name created, which was a prerequisite for the keys to be generated. What if we now try to connect? Now we get a password prompt. So actually they were able to negotiate some sort of encryption between router 1 and router 2. Now those keys are generated and I'm actually now prompted for a login. And we know that we gave the user Ryan the password of A, and now I'm in router 1 using straight into the privilege exec. And if I do the who command again, you'll notice that the user Ryan is logged in from router 2, and then again I'm here logged in from this box that I'm currently on. Now what if we open up Wireshark? If we go ahead and open up Wireshark on the local LAN connection, which is to this particular lab, and we generated some traffic, let's just send some commands, you see that we can actually get, let me just, well, there you go, let's put it, that'll do. All of our traffic here is actually using the SSH protocol. We can see on the right hand side, just in the info tab, that Wireshark has picked up its SSH and therefore encrypted. And previously, when we went down to the follow option and followed that TCP stream, we could see everything that I was typing. Well, now you can, because that communication between the two routers is encrypted and secure. So what have we learned then? Well, we know that very similar to Telnet with the VTY configuration, except for we have to change the transport input command. But more importantly, the difference is SSH is secure, but to configure it, we have to have a domain name, because that's a prerequisite for creating those keys, and those keys is what allows router 1 and router 2 to actually encrypt that traffic, to agree on that key exchange in order to perform that encryption. So while we're here, let's have a chat about banners. Banners are very straightforward. If we go to config T, within here we have the keyword of banner, and then it gives us an option to create different types of banners. Now you don't have to know about all these banners, but it's certainly important to know about the MOTD, the login banner, and the exec banner, and understand when they appear depending on where you are in the Cisco and who you are logging into the Cisco. So take some time out and test this in Packet Tracer. When you create a banner, it's very straightforward. You literally type banner and then what type of banner you want to create, and then you need to actually give the Cisco what we call a delimiting character. And ultimately, this means that until the Cisco sees this delimiting character, you're able to create a banner. So what do I mean by that? Well, if I leave the character as C, which is the default given in this example, then it means that I can type anything I want in my banner. I can do any kind of ASCII art or whatever I choose to do. But as soon as I type the character C and press enter, it takes me out of that and applies that banner. So what you'll need to do is think about what character you would like to use that will not be present in your banner. Otherwise, you would close that field quickly. So for example, if I use C, I couldn't use any words that begin with C. So normally your delimiting character will be a random character on the keyboard that's not used in the actual banner itself. Now the other important thing about banners is what you put in the banner. A very poor banner would be something like this. Never welcome an unauthorized person. It's really important that your banners state that if they're not authorized to connect, they should not connect. And some banners would even specify that if they're unable to connect or they have access to a box and they shouldn't have access, to actually contact the NOC of that company. So it's really important that your banners are not welcoming, because one of the key bits with banners is it's vital that people that approach the front door of your Cisco knows that they're not allowed in unless authorized to do so. That means that if the Cisco isn't locked down for whatever reason, maybe someone's removed an access control list by accident, and someone's hit the front door of it, it's important that at least there's a banner there to tell them that they are not authorized to connect. Otherwise, it won't hold up in a court of law if someone did connect to the Cisco and sabotaged it. So, bad example, you would normally say, no unauthorized access. If you do find yourself having access to this device, please report it, or whatever it may say. There's plenty of examples online of what banners can do. I've seen all sorts of silly banners and some really informative banners. Sometimes I've seen banners used, or different types of banners, like the exec banner, used to actually tell engineers what's actually on the box. So for example, VLANs 500 to 1000 are reserved for X, Y, and Z. It's not an ideal way of telling engineers what's actually on the box, but it certainly helps if there's nowhere else in the company to put that. Certainly not good practice. But here, let's go ahead and create one. So here we're going to say, so this is my lab, and then when I'm happy for it, I would use that again, that delimiting character, and then it would take me out of it. If I then from over here SSH into it and connected, you'd get the message of the day banner straight up. So have a go with these banners. Again, the exec banner, the MOTD, and the login banner. Have a look at examples online. Make sure you understand that banners are there to inform engineers as they log in, but also ensure that it tells people that if they're not authorized, they should not connect. Very important there. Okay, so that's what we've got time for in this video. So let's go over what we talked about. So first of all, if you haven't watched it, watch the previous video. That's a key point. Both these videos together give you all the information you need about TCP, SSH, and VTY lines and so forth. Make sure that you know that SSH uses port 22, TCP, and more importantly, it's secure, unlike Telnet. All the previous commands we used, like the local usernames on the VTY, apply to SSH. VTY is not Telnet configuration. VTY is the terminal access configuration or remote terminal access configuration that's used by protocols like SSH and Telnet. Therefore, all the configuration commands that we've discussed so far in these videos can be used for SSH and Telnet. So they apply in the same way. Make sure you really understand that the domain name is a prerequisite for those crypto keys, and those crypto keys are required for that encryption. By default, it's that 512-bit, but you do have the option to use version 2 SSH, but your key bits has to be higher. I wouldn't necessarily need to kind of remember what is the default key bit. kind of only remember what's required for SSH versus Telnet, because they may again give you a incomplete configuration and ask you why isn't SSH working, for example. So a key thing to remember is under the Telnet VTY command, make sure you know about the transport input and the different variations you can have with OR, SSH and Telnet. Banners, we've talked like a few minutes about banners. There are different types of banners like message of the day, the exec banner, login banner. Go create them, play around with the VTY configuration as well as creating the banners, and see how different banners appear through different processes. So which banner appears when certain users log in, and where along that process does the actual banner appear. So the key thing that I keep telling people is to play in Packet Tracer. Every time someone asks me why, what's the secret to passing the CCENT, what's the secret to passing the CCNA, there is no secret. All you have to do is continuously play in Packet Tracer, find all the bugs in Packet Tracer, and actually live in there for a month or two, and you will certainly have your CCENT. Hope this video has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.